think we're good to go. All right, so welcome to the Handmade Seattle podcast. Handmade Seattle is a developers conference. I would say, hopefully, one day, the leading conference in Seattle for low-level programmers. This year, we are going online for all the obvious reasons. But I am very excited to be able to do a podcast with three wonderful compiler people. And I actually want to get to know them a little bit before we get started. So let's go with Andrew. Can you hear me, Andrew?
Hey, Abner. How's it going?
It's going fine. I think by the time people listen to this podcast, hopefully things will be much, much better. So, yeah, I want to hear a little bit about, your professional history with compilers. First of all, guide me through sort of like your perception of what a compiler was to you when you first got interested in it. And then, what made you want to work on the Zig programming language. So just give me a little bit of a timeline of how Zig started and where you are today.
Yeah, that's a fun question. So I think one thing that's interesting about my professional history with compilers is that I have none. I got into programming doing web development for startups. And I've always loved programming and I've always experimented with different kinds of apps. I've done game jams and I've done just fun applications for people and stuff. And I felt like I was getting shoehorned into web development, and I didn't like it. So I started tinkering with LLVM a few years ago with the Go programming language. And I did a side project where I statically recompiled NES ROMs into native executables. And so that was not professional, that was amateur, right? But I had a lot of fun with it. I think that was the spark. So why Zig? I would say that as I've done more and more programming, I've sort of developed a style of coding that I like to do. And it's very focused on correctness. I want to make sure that all the control flow handles all the possible errors. And I want to make sure every case is handled. I don't want to silently ignore situations or something like that. And I want to make sure that the code is not wasting any CPU cycles. I want to make sure it's only doing what it needs to be doing. And I felt that no matter which language I tried to use, there was always a stumbling block that would prevent me from having my preferred style of coding. So that's why I started on Zig. And then you asked... Oh, go ahead.
No, sorry. So these days, when you work on Zig, how can people... find you? Let's just put that there early on here, because maybe somebody's already interested in Zig. How do they find you? How do they contribute?
Oh yeah, I'm really involved in a bunch of the communities, so it's really easy to find me. So I did this thing where I put on the wiki that the Zig community is decentralized. So I don't run it. We have an IRC, we have a Discord, we have there's a Russian Telegram group. There's a whole bunch of other places. They all have different moderators, different rules, and I'm in some of them. And so you can just pick one that I hang out in, and you can say hi.
All right, you can...
I don't speak Russian.
No,
though, so.
right. But there might be some Russian people here in the chat, so that could be something they could...
Oh, great.
Yeah.
Okay.
So, all right, what's your relationship with the LLVM project these days? Do you use an LLVM backend for your compiler or not?
Yeah, that's a good question for Zig. So early on, Zig was tightly coupled to LLVM. But lately we've been adding a self-hosted backend that has no dependencies on LLVM. And so my relationship with LLVM is it was training wheels, and now we're starting to ride a bicycle.
Yeah.
We've also contributed back to LLVM quite a bit. So especially this, I want to give shout outs to this contributor who goes by Lemon Boy. He has worked so hard on cross compilation, and he's filed upstream bug reports in LLVM. He's written patches for LLVM. He's written patches for the LLD linker. And then right now, LLVM is trying to release 11. But I've filed 4 to 5 release blocker bugs because the Zig test suite caught regressions on various architectures. So we've been a pretty responsible open source citizen with regards to our relationship with LLVM.
And before we move on to some of like the other compiler people we have in this podcast, I do want to hear, when it comes to Zig, you started it, I think, as a hobby project, but it has evolved into into a serious full-time endeavor. Am I correct?
Yeah, that's absolutely right. So people called it a toy language early on, and in my
Right.
in my heart, I knew that it was going to be big, but I didn't call anyone. I didn't argue with anyone. I just kept working on it, and yeah, it was moonlighting, right? So I would work day jobs and then do evenings and weekends, which was exhausting. And I'm really thankful for the financial support that I get now, because now I get to do it full time.
I mean, there are times when a compiler project can just stay a hobby thing, and it definitely helps you professionally either way. Like if all you did was learn compilers and maybe write a toy one, that's already a very powerful thing. But the fact that you also went beyond that and made it a professional thing, and it's been successful, that might be hinting towards a desire for languages that sort of are different in some aspect from like C++, modern C++, Rust, and we'll get into all of that. But let's for now introduce our next podcast guest, which is Ginger Bill. Hello, Ginger.
Hello, good evening. How's everybody doing?
It is absolutely an honor to have you here. So Ginger Bill, for those who don't know, I really doubt that they don't know, but it's possible. He has been part of the Handmade community for years now, and he started his own programming language that has similar goals to Zig in some aspects, but definitely not in a lot of other aspects. But they're still sort of like vibing in the same space. So I'm happy to have them here together. So tell us a little bit about your professional history with compilers, Ginger, and how Odin has evolved up to this point.
So my professional history of compilers is technically zero, except in some very rare cases where I would class them as compilers, most people wouldn't. So things like G-code, which is flat CNC machines. But in general, none. Most of it's always been a hobby for me, like compilers and languages for quite a very long time, actually. And that's kind of my history. But the evolution of Odin from learning about compiling stuff, came out from frustration of C and C++. The Odin project started around about in July 2016 when I was programming in C and C++. I was getting very, very annoyed one night. So I thought to myself, you know what, I can do a better job than this. So I just started programming one night. It started off as literally a Pascal clone. I even had the begin and end everywhere, and it was all that lot. So even though I wanted a better C, I went to a completely different tradition, which is the Pascal tradition. And the reason as to that is that is how I learned to make compilers, is from reading the Oberon source code, which is a derivative of Pascal, and also learning stuff from Niklaus Viet and many of his books on the topics. And I always recommend people that's where to go to learn how to make a compiler, because usually there's one book I always recommend, which is Algorithms plus Data Structures equals Programs. The entire book tells you how to make the language that the book's written in, which I absolutely love. And it's very pragmatic and down to earth there. The evolution of Odin, though, was looking at what are the actual tools that I wanted from a language and actually just kind of put them in there. So it was this is what I need. Okay, put that in there, in a sense. It seems a bit, rather than like a bottom-up approach, it's more just like, it sounds a bit hodgepodge at times, but it really isn't. Because a lot of the stuff when I'm looking at language design, you see, what made this language good and which aspects were good and why was it good? So the evolution of Odin, I think within about 6 months, I pretty much nailed exactly where I wanted to be. And then the details kind of filled in over the years.
So it sounds like it wasn't that academic of an endeavor. I'm not a compiler writer myself, but I have worked alongside compiler writers for many years. And it's funny because those that are like more practical in terms of actually writing a compiler for people to use, they do reference literature. They do reference academia, the formal way of, okay, so we can write a lexical analyzer, and maybe we can do it in a table-driven way, or maybe we can keep it simpler and then move on to the parser. Is it going to be LO1, recursively descended, and then we're going to move on to the next stage? So it's very rigid. There's a lot of steps to it that takes you from, okay, text on the screen all the way down to the machine code. but it's always been very rigid. It sounds like the way you're talking about Odin, though, is that you wrote the compiler, yes, with some understanding of academia, but it sounds like you also decided to go your own way, in a sense.
Yes, because my background is I've not got any academic background with programming. My actual academic background is physics. So it's quite a bit different domain entirely. But for me, when I was making programs, I need to learn the tools to do the problem solving. And the way that I learned was quite practical in that regard. It wasn't theoretical. So all of like the technical terms like LL1 parsers and recursive ascent and stuff, the basic things like that, I learnt afterwards. I didn't know the names of them. I just realized, oh, this thing I've been doing has been called X, Y, or Z. So I kind of put the names to things after I learnt the concepts.
And let me bring in Andrew here for a second. And I know we have one more guest to introduce. He'll be coming in very soon. So Andrew, was that a similar experience with you in terms of you wrote a compiler maybe with some academic understanding, but not that much?
Yeah, that's absolutely right. And I think it's interesting because there's certainly a lot of material that academic experiments and papers have to offer, but that can be pretty inaccessible for various reasons. And what I've found is that if you reason yourself about the problem and you implement a solution, you're going to land somewhere in the range of what the academics of compilers are doing. And it's not necessarily going to be on the worst end of the range. You might actually be like pretty up there with the state of the art, depending on what you landed on. But the thing that's neat about figuring out your own solution is that the academic paper has to abstract so much stuff that it wouldn't necessarily plug into your compiler. But when you're reasoning about the problem, you actually have these details and you can couple your solution to them. And that's just something that like studies can't do because the devil's in the details.
That's true. On that note, we do have a guest here, and his name is Josh Holzman. I'm going to ask the moderators to put the Twitters and the websites of all of these wonderful guests who has worked on compilers both as a hobby and professionally. So, Josh.
Hi. Yes.
Excellent. Welcome to the podcast. So, as a user of different languages, I think all of us use different languages. One thing that worries me, and this is why I like, sort of like what Tekla has been trying to do, and what Odin has been trying to do, and what Zig has been trying to do, is the fact that languages like modern C++, and I don't mean to trash languages necessarily, but I think it's an observation that things like modern C++, maybe sometimes even Rust, they tend to casually bring in hidden complexity. If you're somebody that's working on a graphics rendering layer, the Vulkan API is already a very complex beast. At the very least, because it's vanilla C, I can get used to it. But then when I look at tutorials online for Vulkan, they're all using modern C++. In fact, when you look at Vulkan helper libraries, Vulkan wrappers to sort of like make the Vulkan API simpler, none of them have vanilla C, which is the language in which the API was designed, right? And it seeps into tutorials, it seeps into teaching. If you go to the most popular Vulkan tutorial, you're importing a 3D model, and then the 3D model, you want to deduplicate the vertices from the mesh because you might have way too many duplicate vertices, and that's not a good idea. So the author goes into importing an unordered map in C++, goes into overloading several operators, and then designing a template specialization for a custom hash function so that then they can use vertices as the index to the unordered map and then store only the unique ones. But here's the thing, I chose to not do that, and I went with vanilla C, and I just did a single loop, and I iterated over vertices, and I did a memory compare. Obviously, that's not going to scale. If you have a million vertices that you're loading from a model, my single loop and memory compare is just not going to scale very well compared to the C++ version. My program of that tutorial, the vanilla C version, was faster. The program actually compiles faster too, right? I'm wondering, like, what do you guys think of the state of modern languages? Do you agree if it's easy to like casually bring in that hidden complexity like that?
Yeah, I think you made a really good point about bringing in those standard template library abstractions, because it's a tutorial. It's supposed to show you how to use Vulkan, not C++. And I mean, it would have been more fun for the person learning Vulkan to make that leap on their own to use a map and deduplicate it. It'd be nice if they got to make that jump instead of being sort of force-fed this abstraction. But yeah, as far as Zig goes, this is sounding very on point because there's quite a few things. I mean, if you go to the homepage, you'll see that one of the things that we advertise is no hidden control flow, and there's a bunch of examples of other programming languages that have hidden control flow. And as you mentioned, one of these is operator overloading. So you just can't do that in Zig, and that's like a debated topic, right? Some people don't like that; they want to use operator overloading. But the fact that we don't have it is sort of a good example of the strong stance that Zig takes on it. One more example is that we don't even really have the ability to allocate memory unless you're given an allocator as a parameter. So you can actually even use the standard library if in a freestanding mode. So like if you're writing a kernel, you could even still use the Zig standard library because nothing allocates memory.
That's amazing. How does that compare to Odin, Ginger?
Yeah, so just to carry on from the last bit, the allocator.
Yeah.
So yeah, Odin has allocators as well. So it has extensive use for Odin, allocators in the language, but it's through a context system instead. So instead of having an explicit parameter to each procedure where you set what the allocator is, it's in this. You can do that, but the default way is to use the context allocator, which stores like a normal allocator, temporary allocator, and such. And it's more of this is the general way that every day to day, this is kind of what you're doing. And it's usually context-based, what your allocations are. And the reason for this as well is that it allows you to modify third-party stuff when they were being kind of lazy and they didn't explicitly stated a allocator. And you could always just make sure everyone does the convention, but sometimes that doesn't case. And sometimes you don't want to do that either. And this is where it's come to the main question you're asking is, my general philosophy is that simplicity is complicated. Because what do you mean by simple? Because many different people have different conceptions of simple. Some people mean it's small. Some people mean it's easy to comprehend. Sometimes it's clear. These are all different concepts with different ideas to them. And it is one of those things where if you're trying to be simple, which is something you should strive for, but the thing is, which one? So, I mean, very seriously, some people, let's take Lisp as an example.
Yeah.
I would probably take with Lisp is everything is an array, effectively. And it's built up from that simple idea of all these built up, and you can build up and generate all this cool stuff from it. Mm-hmm. To me, that isn't actually simple, because once you've had that concept, it actually brings in other things that require it. Many different Lisps also then, it doesn't really reflect the computer itself. So it's not simply mapping to a computer. It doesn't require, many Lisps also have very weird, complicated memory requirements. So that's not simple anymore in there. So you've traded one simplicity for another. It's trade-offs everywhere. The entirety of life is compromises. There's no change for programming languages. So for Odin, the thing I was optimizing for in simplicity-wise was more of keeping the amount of features to a limitation, and more of another metric was, could I actually memorize the entire specification? Could a mere mortal know it? The C specification, I could just about do it. The Go specification, I've done it. I forgot most of it now, but I did actually memorize it for about a year or two. C++, not a single person on the world could. So that's kind of my metric of simplicity, but there's so many.
I just wanted to laugh and say that's amazing. And I loved your point about what does simple mean. That's right. That's right on point.
Yeah, thank you. Yeah, a lot of times people bring conceptions to the table, like a model of how things work, a worldview, you could call it, and they don't even realize it. And everyone's just thinking, it's obvious what I mean. I'm like, no, it's not obvious.
I would like to throw out there one possible definition of simple that I feel is the one that Zig subscribes to. I think that there is a concept that exists in information theory about just like depending on something. So As an example, let's say that I want to choose a file path on the computer, and I need to translate some random bytes that I got from, dev random or whatever, into a file path. Now, here's two choices. I can use hex to convert, 8 bytes into a file path, or I can use space 64, replacing like plus and whatever, like those two characters with like some ASCII-friendly characters. Okay. Now, in almost any language, it's going to feel like the same amount of complexity because you're going to have a base 64 encoder and you're going to have a hex encoder. No difference to the programmer. But in terms of information theory, one is actually simpler. The hex encoding is simpler because it is just mathematically like less of an interesting transformation.
I like that. I like that idea of simplicity, and I've actually encountered what simplicity might mean, and you're right. So like if we compare Vulkan and OpenGL, OpenGL might allow you to update uniforms, in your shaders just by calling GL uniform per frame, and you just do that one call. Vulkan lets you think about uniforms as a buffer object backed by device memory, and you can offset into that buffer, which you need to do anyway in order to make like partial memory writes to update certain shaders in a more efficient way. So you're talking about efficiency and memory storage and all of that. But I actually found that to be simpler, at least for the driver. And this is what Ginger Bill was trying to say, I think. Simplicity in what dimension? And for me here, what I care about as a programmer trying to write software is the user experience. Not necessarily a compiler writer, but just a regular programmer trying to ship software. Josh, I want to hear sort of like your take on simplicity, because I'm sure you've experienced this with like when you're writing in your hobby compilers and maybe talking to people in communities. There are mindsets that are attached to a language that somebody uses. So not to dig on C++ too much, but I have a lot of C++ friends who might say, for example, oh, don't you dare write a struct that is having more than 100 members, right? In the meantime, I'm looking at a Vulkan spec with a struct that has over 100 members. So what do you think about like sort of like the best practices that are tied to a language that sometimes they may make sense to you or they may not make sense to you, like the idea of like having a class file that is no bigger than 100 lines of code? Like, do you subscribe to stuff like that, or do you find simplicity in other ways? Like, what's your take on this?
Well, how I approach generally building any piece of software that I work on, I don't tend to split up my code early on. I tend to write everything in line in one file until I've exhausted enough of the concept that I'm working on, where it is a more or less self-contained thing that can exist outside of the thing I'm currently working on, right? So my form of simplicity is to cram everything down together until something starts working, and then start splitting things off where it makes sense. And I guess that's kind of helpful because then you know what you are building after you have built part of it, rather than trying to preemptively build the organization aspects of it.
But then that means something like Java wouldn't be the ideal language for you.
Well, I mean, you could technically write everything in one file in Java, but you probably would not make a lot of people very happy.
Because, when you start with Java, you immediately start a class that is encapsulated and modularized. So I feel like you would be fighting against the grain and against the community with your style, with your approach. And that's not to say that somebody can't write great Java software by cramming in everything in one file like you're saying, right? But I don't think the language would encourage that. And so let's actually segue into this with like Odin and Zig. Let's go with Odin first. Simplicity in terms of organization and scaling software. Like, what language features do you provide for encapsulating scope, for dealing with namespacing, for gradually adding more and more code in blocks? Like, what terms do you use here? Like, is it a module? Is it like, how do you allow for libraries? Like, all that stuff. Like, how does Odin work with that?
Well, Odin, it was actually a hell of a lot of experimentation. So for what you'd call the package system or the module system, whatever you want to call it, the same word at the end of the day, this took me about 18 months of experimentation and different designs and trying different things out and how different languages deal with them. The thing that you are trying to do at the end of the day is some form of encapsulation. There's the OOP approach, which is encapsulating at the type level. But from personal experience in general, I think it's the wrong level of abstraction. there isn't. It's not very useful for you to do that. And I think I'm going to just say it, the modular approach, modular 2, those languages, they got it right. This is how they do it. The best level of abstraction is the library. But the question is, why is that the right level? Why is it not the level of the procedure, or is it the data type? Why is it that this library, a collection of these data structures and algorithms? Why that? And secondly, how do you structure that library? And that is actually a really, really hard question. You can usually split them into 3 categories. It's the way I came up to it. The first one is C-like, which is include, which is textual include. This is actually got a lot of benefits to it and also a huge amount of downsides. The first one, the first benefit easy is it's simple. And you have actually, I mean, I sound like, what do you mean? But it's simple in fact that it's simple to implement. It's also simple to conceptualize. It's just very linear, and it pretty much says this is one giant file, effectively. The downsides are you've got namespacing issues. You're then going to have namespace collisions everywhere. Each file isn't actually really a file. You just made one mega file. So you've now lost the conceptualization there. The other approach is what I would call the Python approach, which is file-based. So every single file is its own little scope. And then you import every little file. Makes sense? No problem. It's very simple. This is because every file system has files. It's kind of in the name. So you're taking advantage of when you're writing your code into text, that is a kind of a scope for itself, organization. The problem which I've had experience with writing a huge amount of Python is on a per file basis, people split them up into tiny little things, and then it's hard to track where things are going as well. So people will start importing certain entities from a certain file, or dump an entire file in there, and then you've lost track of where everything is gone. So the organization is gone, and you don't know where code is coming from. So it's very difficult to reason about. It's just so that becomes a structural nightmare. And then another issue you have is if you want to separate code across files, not for a library reason, but another conceptual reason, it starts becoming a little more difficult as well. So this is where it comes to the third approach, which is I call the modular or Odin, or even it's technically from in Go as well. These are the different languages. And this is the directory is the library. And I found this to be the best compromise, even though the rest they're all bad. But it's the best compromise I could find. So in this case, it says the directory is the thing, and all the files that are like .odin are seeing each other, and they can all see each other. The thing I did differently is also each file has its own little scope. So if you import another package, the import names are local to that file. So it keeps it very local, and you know what you're doing. So it's very nice to conceptualize what you're using and what you're doing. So and it also helps because a lot of the time you'll just want, your library will have more than just source files. You'll have lib files or DLLs or other resources, and you usually do put them into that. And just to go 2 steps back, actually go to the C, many people in the Handmade community will love single header file libraries for C, because they're very easy. You just drag and drop them in and it works.
Josh and I are huge fans of that.
The thing is, the reason why they're great is because C doesn't actually have a concept of a library. And because of that, it's ill-defined how to import everything. So you're having this thing, it simplifies the include system, the build system, everything, and that's the main benefit to it. If your language well defines what a package is, a lot of things just fall into place, and that's not even a problem anymore. Including, so single file libraries are lovely, but they're not. I wanted them originally. Turns out it's a pain to have. It's a big language. This will be an hour topic in itself, so I won't go on to more. But yeah,
I mean, they're workarounds, right? They're workarounds for C.
Yes, yeah. It's here's the fact of nature. This is C. It's old. It was never really. It just evolved effectively, and it was just like whoops.
So are you guys just trying to, and this is generalizing, right? But are you guys just trying to take all the best parts of C and then add all the, so for example, Andrew, almost all systems have the ability to call libraries written in C. This is, for example, Android applications that are written in Java, Josh's favorite language, are able to invoke, they're able to invoke SQLite. Right, they just use an adapter. So SQLite is, it's vanilla C. What guarantees would I would I have if I were to switch to Zig in terms of that ability? Like, do I still keep it? Like, am I able to write Zig code in which then in the future, some future programming language from, the year 2035, can call into a library that was written in Zig?
Yeah, I want to make a key insight here as to why every language can talk to C. And it's because every language wants to be able to call machine code, but every language doesn't support writing machine code. But C does, and C has a well-defined ABI so that your language can call some machine code functions. That's my key insight on why all these languages want to talk to C. With Zig, you don't need to call into C if you can write the code in Zig, because in Zig you can make machine code. But you might want to call into C if a library already exists that you haven't written in Zig and you don't want to rewrite it. Then obviously you'd want to call C. And yeah, we actually have a really good story for this. Mm-hmm. So there's two major pieces to this. One is that we take advantage of Clang as a library to parse C header files and get the semantically analyzed C information and automatically create sort of like namespace Zig bindings so that you can call into C code. You actually don't have to do that thing that you have to do in other languages where you like make a binding layer. You can, but you don't have to. That's part one. And then part two. Okay, so since we already have libclang in order to do this, I thought, well, wait a minute. Clang can compile C. Why don't I just like rename main to like Zig main or like Clang main? And I just exposed Clang in Zig, so Zig can actually compile C code too. Wow. So if you do like single header files like STB image or something like this, that actually works extremely well with Zig, because you don't even have to. You can compile that with Zig and then C import it with Zig and then just use it without depending on having like MSVC installed or anything else like that. Like using only the Zig compiler.
So the thing I like about that is that, again, this continues to tie back into how we as a community are sort of like defining simplicity. This, to me, the fact that you're properly absorbing C is not a simple task for you, right? Like you're eating the cost.
No, it's a lot of complexity. Yeah.
But then the user who uses this piece of software, because Zig is a piece of software like any other, they massively benefit. And the experience that they get is actually simpler thanks to you eating all that cost up front.
Exactly. Yeah. So like I have to do a bunch of work whenever LLVM comes out with a new release like it's about to do. But in return, like Zig users don't have to install MSVC, and that's simple for them.
You're absorbing C in a way that, well, continues to let people work with C if they need to, but then they can also move beyond it. So that's pretty cool. Josh, in terms of your experience with like using different compilers, many of them, I don't know. C language is old and boring, right? It is a well-known language. It's well understood. That's exactly like what I would want to use. But I know that you have used the Swift compiler. I think you've used Objective-C because you've developed applications on Mac, and you've actually compiled at Tekla, the JAI compiler. You have ported it, to Mac. You have ported it to Linux and stuff like that. So sort of like run us through your experience of porting compilers to sort of like different operating systems. Like, how difficult was that for you? And are you trying to do, both for your hobbies and for your jobs, are you trying to do things that are similar that Zig is doing, where you're trying to make sure that you're eating the cost personally and then you're making lives simpler for users? Or is that a long-term goal?
Right. So there's kind of a couple of questions there, but I'll start with the porting thing. Generally, porting a compiler is pretty straightforward between Mac, Linux, and Windows. There's general issues with regards to which threading API am I going to use on this system, and things of the matter like that. But when you get to something like Linux, you start ending up with a number of issues that you might want to think about. For example, the GNU operating system has a particularly unique ABI preservation system that they call symbol versioning, right? So if you wanted to compile a piece of C software on a modern version of the GNU operating system, it will have newer versions of symbols that aren't available on older versions of Linux, right? So you wouldn't be able to run that program on an older Linux system.
Are you talking about glibc specifically?
Yeah. Well, I mean, glibc obviously has a ton of it. There are some other software that ships on GNU that also does this.
Sorry, I don't mean to interrupt. I'm just curious, like, what, in your experience, what parts of the compiler depended on these libraries, and what functions were they calling and stuff?
Well, I mean, generally the C library, but the main thing I want to highlight is when you want to compile new software with your compiler, right? So, like, in C, there's a compiler directive that you can invoke that like tells GCC or Clang what version of the symbol to use. And the Jai compiler allowed you to append an @ symbol and then like the version you wanted to use.
Gotcha. Right. So you're talking about not necessarily the compiler code itself porting to multiple operating systems or to Linux, but the programs that you're generating with the compiler.
Right.
Gotcha.
Yeah, I think, I don't really know how Odin and Zig handle this, but like, unfortunately with the Jai compiler, there isn't a easy system to deal with this. So you would have to explicitly tell the version of the symbol that you wanted to use if you wanted to use an older version for older compatibility with Linux. Right? If you guys would want to tell us how Odin and Zig handled that, that'd be cool.
Zig actually has a really interesting story in this regard. So I got really excited. I hope I didn't interrupt you there. So there's like two angles to this. So the first angle is that when the Linux so porting the compiler itself to Linux, we ship it with statically. So it actually doesn't link glibc. It's statically linked. Like if you go to the ziglane.org download page and like get the exe and you like find out which like it doesn't even link libc, not even libc. And the reason that works is because Linux kernel has the syscall ABI is stable. So you can just do your syscalls in assembly and the kernel guarantees it will not break your code in the future. So that's for like the compiler itself. And then like as for generating executables, I actually spent like a bunch of time and like figured out how glibc works and stuff. And Zig actually will build the static parts of glibc for you. You can tell it which version you want to target of glibc, and it doesn't read any system files. Like this is that simplicity thing again, right? Like it's looking only within like the installation directory of Zig, and it will build like any version of glibc for you that you want, like the dynamic parts, not the static parts, so that you could then ship your generated executable to like whatever target you wanted, whatever glibc version it had. But then also you could just choose to not use glibc. You can just build a static executable, and then you don't have this problem at all. It works on every Linux.
Well, then I also have a question for you. Then, if you want to use like OpenGL, obviously you can't statically link OpenGL.
Yeah, that's a big topic.
How do you work with that? Does Zig have something to resolve that?
This is my my Moby Dick whale. Is that what it's called? Yeah. I haven't solved this yet, yeah. But it's my dream to be able to produce static binaries that can do graphics and windowing and games and stuff, and work with any libc, like any Linux distribution. I think it's possible, but I don't think anyone's done it yet, and it's going to be hard.
That's fascinating. I think that, this is going a very different route from like what I would see like in the other languages is that the problems that you're trying to address are specifically about evolving C, but still keeping the things that people loved about it, right? So I always fear that communities in other languages, and I'm not trying to trash other languages or communities. It's just we're trying to carve out sort of like our own place here and stand alongside these other communities. So, something like, something like C++, something like Rust, something like Java. I always have felt this sense that what the core maintainers or developers are trying to do is put kid gloves in our hands and make sure that we don't actually have to think about peeking behind the curtain. Like if you can avoid peeking behind the curtain, if you can avoid thinking about pointers, how to address memory, how to call into system libraries. If you can just stay at a high level and like focus on business logic of your software, right? Then that's the ideal path. I just want to know, how much trust do you put in your audience when you're writing these compilers? Are you focused on the audience at all? Is this more for yourself?
For Odin, at least.
Yeah.
I'm just gonna, and here I was just saying is that it is a tricky balance. What you're trying to do is again, I'm going to just quote Spider-Man now, is with great power comes great responsibility. But this is the thing. You can allow people to, you can say, look, I don't trust people in general. Again, don't think people make mistakes all the time. They're going to throw the show off. But I say, nope, you're allowed to do whatever the hell you want, as long as it doesn't affect other people in that regard. So it's like, yes, you're going to make mistakes, but I'm going to allow you the tools to do it. Now, the question isn't allowing the tools, because again, all our languages are very they're just, I say, a bit higher level than C. And C is a high level language, but it's still a bit higher level than C, but not too high level. You're not abstracting so far away from this basic model of how a computer works and trying to abstract that to the heavens. But the problem, the problem here is that when you are trying to abstract far, you lose a lot about what you're trying to do. So again, we're talking about the best aspects about C. I'm just going to go back to that slightly. C nailed something right, and it's taken us decades to figure out what that thing was. And that may sound weird, but let's just look at the basic days of computers. How you program a computer was literal the bits and the bytes, and you're programming it manually that way. I'm just going to paraphrase. This was von Neumann, the very famous polymath. When assemblers were coming along, he thought that wasn't proper programming, because proper programming involved writing the actual bits and bytes manually, machine code. That was programming. Assembly, that was cheating. That's not real programming. But the thing is, assembly and machine code were very tightly linked, because it was a very direct mapping to one another in the early days, at least. Not nowadays with macros and macro assemblers and stuff, but assembly language and machine code were one-to-one. You could see the exact mapping what's going on to the machine. So there was not very much of an abstraction going on. The abstraction was just make it human readable. C, on the other hand, was the massive leap, and it's a different way of looking at the world entirely. And when you look at it, C is added all these new constructs to it. It's now got this, it's like, okay, we've now got explicit control flow, and you've got structured control flow. You've got data types. You've got operators. You've got many other functions. It's like, there's loads of these different things that just pop up, which didn't exist. And it's like, okay, so what's happened? What's gone on? Mm-hmm. And the way my hypothesis is that assembly and machine code is more of like a set theory based thing. It's like, here's a set of instructions, and the instructions themselves defined how the data is operated. While C took the leap to type systems. So this is type theory. And it said, no, types are the things that restrict things and tell you what goes on. And those types will map to instructions, but it's the types to attempt to say which instructions should be used, not the other way around. And from that, you can also get more structured behavior. The second thing that C got right is it actually structured programming. That is the correct way of programming. Which I might sound like very assertive here, but no, that is the correct way of thinking. It's the correct way of logically actually solving a problem in your head. Mm-hmm. That's how you do this, else this, then that, and this, that, and this, fine. Also the structuredness with scopes and blocks and different subsets of different operations, perfect as well. So understanding those two basic essences that C got right can tell us where we can go in the future for any other language and why they copied C.
I mean, that would be my ideal dream, is that people making languages today, including yours, but others, is that when they see C, is that they see a portable, it's a classic way of saying it, just a portable high-level assembler in which you're still aware that what you're programming is a computer. Real computers with CPUs and L1 and L2 caches, and then you have to think about the bus in between the graphics card and the die. Like you're thinking about the hardware, yes, at a high level, but you're still thinking about the hardware. Sort of like it's felt to me like the pendulum of software quality, at least some commercial consumer stuff, is like going in the opposite direction. Like we're optimizing so much for the convenience of the developer, the convenience of even the compiler writer, that the actual software that comes out at the other end isn't really that important. And that's the feeling that I've been getting. And it seems like stuff like Zig, stuff like Odin, efforts from Tekla, and so on, it seems like they're finally valuing C in the way that I was hoping other languages years ago would value C.
Just to butt in for 1 second,
Yeah.
I think the reason why is because people don't understand what programming actually is. I mean, that is like a very simple thing. I'm just going to quote myself here. I've written this all down before. Programming is a tool to solve problems that you have in the domain of computers, right? Mm-hmm. So, in my definition, I'm just going to do it here. You're solving problems you have on a computer using a computer. So that means a computer works a certain way. That means it restricts how you solve that problem.
Okay.
So that's the way you've got to think. It's like, okay, so when you're dealing with it, you're not dealing with this random abstract platform of how you want it to work. No, actually, the domain sets it. The second thing is, the purpose of a program is, and ought to be, something that transforms data into other forms of data. And that's fundamentally what a program is. And when you understand those two kind of things together, in my opinion, this is how I think, you start thinking more about what you're developing on as well as what you're developing for, because it's not some abstracted thing away that you're solving something with certain constraints.
Josh, and Andrew, are you vibing with us right here? Or I hope I'm not like putting words in your mouth with like how I see things.
No, totally. So, yeah, I mean, the way that Zig advertises itself, like the banner at the top is a general purpose programming language. And to me, what that means, what general purpose means, is that you support a lot of different places that your code can run on, right? And so that's going to translate to CPU architectures, x86, ARM, RISC, the older ones, the newer ones that we haven't even come out yet, right? Mm-hmm. But it also could mean that it needs to run in other contexts as well. So, for example, you could have a C backend where you translate your language into C, or you can have a WebAssembly backend. You translate your code into WebAssembly. Maybe you have a brainfuck backend. Are we allowed to say fuck?
Yes.
Yeah. fuck. So maybe you have a brainfuck backend. I mean, that would be pretty wild, right? That's barely Turing complete. But to me, it's a little counterintuitive. But to me, what general purpose means is it's supposed to run on any computer. And obviously some backends will provide problems. It'll be harder to make your language run on them. But yeah, that's the idea. You turn the source code into actual machine code.
And Josh, didn't you write a brainfuck compiler recently?
I did indeed.
How did that go?
It's one of my greatest accomplishments. It has a jitter. It compiles to machine code if you want it to. You can link binaries with it. It's amazing.
That sounds wonderful. I can't wait to try it.
Yeah. How many years have you been just being a hobby compiler person, right? Like it sounds like it's been many years at this point.
I think it's been almost 6 years.
Wow.
Yeah.
Okay. Just for sometimes. So tell us what goes in your brain to want to write compilers for fun. Like, I think that's that's obviously a fantastic mindset to have, because we definitely need more compiler people. And in this conference, we're really trying to inspire the next generation of compiler writers, of game engine people, of people writing kernels. We're going to have talks here, people discussing their adventures in trying to exploit a kernel driver bug, and like that kind of skill is still very much needed.
Hell yeah.
Yeah, I would say that if you look at the next PS5, or maybe the next, even beyond that, these are architectures. This is hardware. It's physical stuff. How do you go from there to a working C compiler and a working web UI SDK for the startup screen of the PlayStation, right? Like, how do you go from hardware to that? And it's these people that I'm talking about, right? It's you guys. It's those who still find the value in actually peeking behind the curtain when you need to, right? And simplifying things for the user, and you guys absorb the cost and you actually go through a lot of work to make this happen. But also, you kind of... So anyway, this is fantastic. And the fact that there are people who actually would want to do this for fun, I want them to know that this is possible. And like, you've been doing it, like you said, for 6 years. But maybe tell us what got you into compilers. Do you plan to continue being a hobby person for compilers? Like, what's the story?
Well, for me, I first got into compilers shortly after Jonathan Blow started talking about Jai.
Mm-hmm.
That was kind of the initial kind of curiosity that sparked it for me. But, to continue working on compilers, through as a hobby, there is a substantial personal satisfaction from getting from something that is, very abstractly not the machine to something that is very concretely representable to run on the machine, right? And so once you get to if you start working a compiler and you get to that first hello world program, that is enough personal satisfaction to actually want to smile and celebrate, even though it is an insubstantial program to be able to compile.
Yeah, you kind of want to be able to enjoy computers thoroughly, right? To want to take on compilers, because so much stuff goes into it in terms of meta levels of thinking, right? So not only do you have to understand, I mean, correct me if I'm wrong, but not only do you have to understand how computers actually work, since you're writing a compiler, but you also are writing a compiler using a language that may not be your language because doesn't exist yet. You're also using a different compiler to compile that code that is going to become a compiler. So, maybe walk me through how meta do you get when you're writing compilers? Did you expand your way of thinking in terms of bootstrapping concepts or recursive thinking? I mean, I'm not even sure. How have your skills expanded? Writing a compiler, do you actually struggle, at least at the beginning, writing a compiler because it's just so different from other types of software? Let's go with
I have some thoughts on
Andrew.
this.
Yes, please.
So early on, there was a lot of parts that I didn't have any exposure to, and they were very difficult. So, for example, what arguments do you pass to a linker, right? These all seem they seem unapproachable, before you dive in. What are all these libraries? What is this libgcc? What is this compiler RT? Why is LLVM emitting calls to libc? These are all confusing things at first. Yeah, it's been about 5 years on Zig now, and now I could just answer any question you ask me about the entire tool chain or any assembly code or anything. It's been a wild ride. But I wanted to address bootstrapping specifically because I think that's a really interesting topic. A couple sort of points about this. So one is that going back to Ginger Bill's definition of simple, I think it's interesting to note that C is a simpler language than Zig for the compiler. That's definitely true. And therefore, it makes sense for C to be a stepping stone on the way to bootstrap Zig. It just fundamentally makes sense. So, for example, let's say that you have a new computer and your goal is to get a Zig compiler, but you don't want to copy any binaries to it. You want to source code all the way, right? So the ideal future of this situation would be, you type in a few machine code directly into an executable file, and that's your basic text editor, and then maybe you have a text editor. That's your basic assembler, and then you make a very, very primitive better assembler out of that one, and then you make a really primitive C compiler out of that one, and then you make a better C compiler out of that one, and then you turn that into a Zig, and then Zig compiles itself, and then now you're up and running, right? That would be a nice bootstrapping story. No language is even close to this except for C. But sorry, I get excited about this stuff. But anyway, as far as Zig goes now, it's pretty interesting because a lot of the compiler is already self-hosted, even though sort of the core of it is still in C++ and uses LLVM. So when you do make right now, the first thing it does is it builds Zig 0, and Zig 0 is missing a whole bunch of features. It can't do C imports, it can't do formatting source code. It can't do. There's all this stuff it can't do, and then Zig 0 builds the self-hosted components of the compiler, and then that gets relinked with some of the same C++ code, and then it just like gets augmented with more powers, and that's like what we're shipping right now. So it's not even fully self-hosted yet, but it's like a hybrid.
I mean, that's definitely fascinating. Just as a fun question, like, do you get harassed on whether your compiler is self-hosted yet or not? I feel like that's a very common question.
I think that question comes with like a lot of positive curiosity energy.
Sure, yeah.
Like the more harassment questions are usually different.
Well, what about Odin? I know that Odin at the time of this recording is definitely far along, right? But it's still your side project, and you dedicate time into it when you can. So give us a brief overview of like how is Odin in terms of like usability. Like if I were to download Odin and I want to write a little game in 2D or whatever, would I be able to do that?
The answer is yes. So my actual main job now is programming full-time in Odin, along with a full team of other people.
Oh my goodness.
So I work with Django FX on the EmberGen project, which is a real-time volumetric fluid simulations for game and film. So you make explosions and smoke, and it's really, really cool. And so there's multiple people working on using Odin. Now, that still means the Odin compiler is still my part-time job.
Yeah.
It's not my full-time thing. But the thing is, I made Odin so I could work in it. I didn't want to write... I know it sounds dumb, the compiler was a means to an end for me. And I wanted to write in a language that made me happy, that was joyful to program, because that's what the thing I love about computers. So certain things like that. So the language itself for Odin, I think, is about done. Like, there's not anything else I'm going to add to it or anything more. It's about there. There's one or two things they're only minor things, but that's about it.
Nice.
The compiler, the standard library, documentation.
That's beautiful.
God, those have got a load. Those things have got loads to go. The compiler, I could probably make it run about 10 times faster. It's something when you don't have as much time, you're not working 40 hours a week on it, you can't. Other things take priority, of course. The core library needs a lot of work. Documentation needs a lot of work, and documentation is a lot harder than most people think. Because it's not just writing yes, but you have to frame it correctly so that people it gets there. But regarding like the self-hosting thing, I've always said from day one, version 1.0 of Odin will be written in C++. And then version 0.1, because then it's stable. Yeah. And the version 1.0 will also be adhere to a specification that I've written as well for the language. So it would be specification based. Then version 1.1 will then be written in Odin, so it will be bootstrapped. Because people always ask me, oh, is it bootstrapped yet? And I'm like, why haven't you done bootstrapped or anything like that? And I say, no, it's not bootstrapped. Most of the time, bootstrapping is just masturbatory pleasure. That's all that people do it for. And I always say that to everyone.
Nothing wrong with that.
Well, sometimes I want to make a baby instead. But the thing is, it is one of those where a lot of people just do, cause it's so fun. It's like, I'm doing but I don't care. I just want to get on and do something else. I want to do something.
That's fair. Yeah.
But yeah, that's kind of the thing. But there's many different things in like that. For me, Odin is, again, that language is done. I kind of know what I wanted. There was things I need to experiment with and tweak with to make them feel correct. A lot of Odin sounds weird. Joy of programming is one of my main things I put on the homepage. It sounds like, what do you mean by that? Well, the thing is, when you use it, it's buttery smooth to use in the fact that it feels correct. And that feels correct is not like a mathematical equation. It's like the spirit for finesse. It's an intuition you get. And that optimizing for that is really difficult. And I know if you're designing language, that really is difficult to do.
Let's dive into that. Yeah, let's dive into that joy of programming, because it's definitely been a topic for many years now, where very popular languages, usually with company-backed resources, right? They're going to have sheer PR muscles promoting the language, but that doesn't necessarily mean that the language being promoted is for the individual well-being of a programmer. So it sounds like both Zig and Odin are prioritizing the experience, the day-to-day experience of somebody who's going to use the compiler, which is fantastic. Now, I guess my question here is, what counts as joy for you?
I would actually slightly.
Oh, go ahead.
Oh, I would actually. I want you to finish, but just maybe you can come back to this. I actually would slightly disagree with that statement being applied to Zig.
Interesting.
Yeah, so I would agree as well. I don't
Yeah.
think Zig is meant to optimize for I won't call it ergonomics because it's not ergonomics, but Zig is very explicit, and I don't mean that as an insult or anything. It's very descriptive. It is explicit. Even doing, like, say, a modular operation, you have to be very explicit in Zig. You're explicit everywhere. So you're being optimizing to be explicit as possible when necessary. For Odin, I've tried to minimize implicitness, which isn't the same when you think about it. So maximizing explicitness is not the opposite of minimizing. It's not the same as minimizing implicitness.
No, that's a very fair
So
point.
There's a lot of implicitness in Odin, but there's also a hell of a lot of explicitness. And it is this, unfortunately, it's this finesse of figuring out which bits of which. And you can be as explicit as you want it, or you cannot. So certain things like the context system in Odin is very implicit. It's passed implicitly to every procedure in Odin that has the Odin calling convention in like a reserved register. And effectively, it's just a pointer and it's just on the stack. But then there's certain things where you want them it's very implicit. For instance, Odin has array programming. So if you have an array of fixed length, you can multiply it with another one, element-wise, and it does it automatically for you. Generates, if there's in lines, it orders a loop, whatever, figures out the best way, and orders SIMD as well. And that's a very high-level feature, but it's simple and it's nice to use. But it is very difficult. Like, again, with Zig, I've used quite a bit anyway. I like playing with languages. And Zig is a very well-designed language, but there's a lot of things in the language that are explicit. So as Andrew could probably tell you more, like, for instance, the Sentinel, I'd say the Sentinel-aware types, like Sentinel-terminated arrays and pointers and such. These are very explicit things, which in Odin, you aren't explicit with. And we have different philosophical reasons as to why we don't do it the same way.
We're going to want to dive into that then.
Well, yeah. If I may, I have like sort of a pithy statement I could try and say here, real quick. Mm-hmm. So like we were talking about how Odin is optimized for the joy of programming, which I like that. And here's how I can sort of differentiate where Zig is going for. So Zig is more optimized for the end user of the software than it is for the programmer. So we're actually willing to make programmers do more chores and take on, some more annoying tasks if it promotes the well-being of the users of the software that they're coding. It's a little bit indirect.
That's interesting because, we have been talking about a lot, and I've been promoting this too, where eating the cost of difficult setups and difficult development in order to benefit the user is so important. It's interesting because Ginger, I think, agrees with that. I believe Ginger definitely agrees with
I agree with that statement. It's just a very different way we approach it. We honestly do have completely different philosophies on programming in general and how we have tackled language design and everything. And that's obviously shown by what languages we produced.
Yeah.
And each language is kind of a reflection of its creator, obviously. But it is one of those where sometimes just showing it doesn't always explain it. I always recommend people try every language you can and try it out and see which is good for you, for your purposes. Like, I even recommend Zig to people on my Odin Discord sometimes when I don't like Odin. You might like Zig, try it out. It's like I'm the worst salesman for my own language.
And I also sponsor Ginger Bill on Patreon.
Yeah. It's one of those where it's like, I am quite principled. I say I want the best tool for the problems I'm solving. So if someone wants different preferences about a problem, like, I'll tell them what the better tool is. It may not always be Odin. It may not always be C. It could be Java. Seriously, it depends on what they're trying to do. It is like, carry on, yeah.
Please go on.
Yeah, so I was just saying, like, for instance, one of my it sounds weird. I think, let's say the Go language. Yeah. There's a lot of things. The Go language and the Rust language. Many people compare these, but I don't even think they're even in the same domain of problems. They are solving completely different problems in completely different ways. I think Go is an extremely well-designed language for what it was trying to solve, which is making web servers at Google with large teams with people who didn't know how to program very well or handle memory very well.
Oh my goodness.
Shots fired.
But no, I love Go. I absolutely love it. I think it's an absolutely brilliant. I love it in that regard because it's technically Pascal in disguise.
I'm gonna add
Because
gunshots
who's
to
the
this
designers?
podcast. Pew pew.
Yeah,
It's gonna
yeah.
happen.
Pew, pew.
It's gonna happen.
Yeah.
But no,
Yes.
I don't mean that as an insult. But
Yeah,
Rust
yeah.
was trying to be a different thing. Rust was trying to be safe, very safe in memory safety and exploits and all that lot because it was designed at Mozilla. They were trying to do web browsers. But the thing is, if you look at the two of them, Rust is by the day it's getting more and more complicated. It's getting as complicated as C++. There's no tether to how more it adds to it. But Go it's been not really changed in like 10 years, whatever, how long it is now. So they had a very well concrete idea, and that's what they stuck to. While the Rust ideas is that a lot of it's experimental, and they're unproven ideas as well. While Go is the most conservative language at the moment. Most of the ideas are from the 70s and 80s.
They almost added Zig's try into Go, and then they didn't do
I
it.
did,
for some
and
reason.
I was hoping they didn't. I really hope they don't. But
Oh,
that's
really?
my
'Cause I
personal
thought-
view.
I was actually thinking like, oh no, if they add try to Go, then Zig will be like less far advanced than Go. And I was like, what? Why'd they close it?
So I've spoken about this before, but my main reason why, like in like Zig, you've got error values and the quite interesting approach, and in my opinion, they are the best implementation for exception-like error handling. They're the correct way. If you want exceptions, that's the way you do it.
In Go.
Personally, no, I'm talking about Zig. Zig now.
Oh, okay.
Zig, I think the error handling system, if you like exception-like error handling, that's the best way of doing it. Because it's very explicit and also it's faster as well. In practice, not technically in theory. But the thing is, I don't like that type of error handling. I like it being very explicit rather than just keeping it passing up the stack. I want to handle the error there and now and do it that way. I also want different types of errors because errors are just values at the end of the day. There's nothing special about the type. There's not like an error type. It's just errors. And they're just part of your control flow. So I have a completely opposite philosophy in that regard, which is why in Odin there is no built-in concept of an error type. It's just do whatever you want because different problems have different ways. Sometimes you want an enum. Sometimes you want a union. Sometimes you just want to return a Boolean. Sometimes it's a bit set of all the different things in there. It is highly dependent on what it is.
Something I want to bring up here is that you guys are talking about, okay, what your philosophies, how that might influence the ergonomics of the language and how much you constrain the developer in terms of like which path they can take, and it all depends. But sometimes when you choose a feature, let's go with Go. Go might decide, well, we do want to always return functions that have like an error interface with an error value. So they might decide that that's so important to them, and that's such an ergonomic thing that they don't want to sacrifice. Then that's okay. But then when they're implementing it and they go into the ABI, functions that return, more than 2 words will have problems with the C-based ABI because they're going to have to force those return values of that function to go into the stack. Because usually most C-based ABIs are going to reserve at most 1 or 2 words for the registers, because that's how the C language very rarely returns more than 2 words. So they were okay. I think they've tried it twice now, and I'm not sure they've actually succeeded yet. Somebody can correct me on the chat, where they tried to change the Go calling convention, and they were even okay with like breaking compatibility, because sometimes for them the language is more important than preserving backwards ABI compatibility and stuff like that. So like, do you guys struggle with that, where like you may have some philosophy or some design aesthetic of how your language should be, but then that might play into how things are laid out in machine code at the end, and that may have issues with ABI? Like, do you go through that kind of struggle, and are you okay with breaking compatibility?
Josh?
So for Josh?
Oh.
Huh? What?
Josh, do you want to take over?
Well, my general opinion on this is that you should not break C ABI compatibility, and with good reason, because everyone else is using the ABI.
But why is Go doing it?
So Go isn't.
Okay, so I'm wrong.
So
here. Yeah.
Go is actually, be very careful. So there's the Go ABI, which is internal to Go. And then there's another language called CGo, which is not actually Go, by the way.
What?
So this is where they are very careful. So CGo is actually an extension to Go, which supports interfacing with C. Mm-hmm. But notice it's a one-way interface. So they're calling C, but the C isn't calling Go.
Oh my goodness.
So it doesn't matter what the Go... And that's not actually...
Sounds
I don't
like
think that's a bad thing
abusive
at all.
relationship.
Yeah, I was actually thinking about that.
But I don't think that's actually necessarily a bad thing, because if you're writing in Go, the Go compilation model is entirely different to C. Odin's compilation model is completely different to C as well.
Yeah.
In a sense, Go, it's the way that Go works is you can either think of it as a massive Unity build, or you can think of it as each package is bundled up in itself. And actually, if you want to understand how it works, it's actually really quite interesting how they got all the dependencies working and making sure nothing collides with everything. It's very clever what they've done. And they just built it up from a package-based thing. So the actual compilation model is fundamentally different to C. So you've got these two different ideas. If you want to be perfectly compatible with C, you've got to do everything the same way C did. And that means you've got to pick up all its flaws and all the other problems. Like ABI design is hard.
And the C ABI is not, I'm just agreeing with you. And the C ABI is like not really well defined either. So you actually just have to pick a C compiler and say, I'm matching that one.
Yeah.
Isn't there like a System 5 ABI spec document PDF somewhere?
There is for System 5 ABI. Now, System 5, I hate System 5 ABI, by the way. I don't even think that's that well designed. I don't think it's... it sounds fast. I'll explain why, short answer. And I'm firing shots, don't care about being controversial. Is I don't even think in theory it's that fast. Compared to other approaches, I should say. Even simpler ones. Now, the Windows one, so like MSVC, has got a very simple approach to doing ABI. It's not the best, but it's really simple. It is a trade-off. Like, how do you want to define it? And yeah, it's really complicated.
It's interesting. I think I agree with Josh in that I'm scared that breaking anything with like existing ABI compatibility it's a tough sell. I mean, I feel like Go. Okay, you told me I didn't know about how Go was doing this, but I thought they were just doing it one way and breaking everything because they're Go, right? And they have Google's backing and stuff like that.
No, they are. It's because the Go language is separate from their interface with C, which is C Go. And I can understand it internally. Like in Odin, I've got an Odin calling convention.
I see.
Which is only internal of Odin, because I can do whatever I want. Make it as efficient as I want, do anything particular I need for its need. But I allow you to set the calling convention on any procedure to be C-based or like a standard call if it needs to be a different thing, if you're doing like Pascal style or anything else. Because you want to be able to interface to and from C. It's not just that way. But ABI is a difficult design, like you were saying with Go, where they have sometimes reserved 3 registers for the return type.
Right.
Because a lot of data types in Go are 3 words wide.
Right.
Like a slice is 3 words. It's got a pointer, a length, and a capacity.
Yeah, we have the same approach. I think it's a good one, which is that you have basically an internal ABI, which your compiler is allowed to decide. You don't. It's like undefined behavior for like the programmer to depend on that, right? And then you have sort of like your external calling conventions, which is probably going to be C.
Okay, fair enough.
Yeah, I think we all share that sentiment. That's how it was in Jai as well. And I think most new languages will agree that like if there's always going to be a segmentation between calling out to C code or even having a callback that goes out to C code, right?
Yeah.
And what you decide to do internally.
Let's wrap this up with an actual diving into ergonomics. When you think about C, and again, people listening to this podcast already know that I, as the host, really love vanilla C and really love understanding behind the scenes work of machines, and I'm trying to find ergonomics that improve over C. So I'm very biased in this podcast, but bear with me. C does have deficiencies as a language. Like this is no question about it. Ginger Bill was saying that this is a very old language. Absolutely. We have learned many, many lessons for how long has C been around? Is it 40 years already?
Nearly 50.
My goodness.
Wow.
Yes.
So we know that we have a lot of design wisdom that we should be able to apply to languages that try to actually replace C. And, since we're calling this podcast The Race to Replace C and C++, let's finish with that. I feel like one of the ways to replace it is to actually improve the ergonomics. And this is a topic that everybody cares about, and you don't need a lot of technical understanding to talk about this. For example, when I'm using C, I sorely miss default arguments for my function parameter lists. I sorely miss having the ability to alias types that are actually enforced by the compiler instead of actually defaulting to be an actual int or you cast it away. So like I might be type defing some integer to be called index or volume or whatever, and I don't want another type def alias thing that is also an integer called something else those types to interact with each other and to actually cast transparently between the two. I actually want a rigidity between those two. That's not in C either. I always make mistakes when using switch cases, right? So like I default to, I always do fall throughs by mistake because I forgot to do a break. Like I would love to be able to explicitly do a fall through command if I actually want to fall through. And this is we can rat hole this.
You can enable a switch for that.
There's a switch,
Sorry,
a compiler switch.
Yeah, most compilers have it.
Okay, fair enough. So like yeah, of course. I mean, you have attributes and
stands.
extensions. Compilers have attributes and extensions.
You just need to know that.
No, actually, it's actually good that I know this now because I forgot. But like, yes, there's definitely that's another thing. C has been corrected, sort of like at the compiler command line level. So like, you might want to call GCC or Clang, and then you can also annotate your C code such that some attributes and some extensions let you do some of the things that you want to do. But it's still not the best solution. Like you're tied to the compilers that allow this. So like it won't actually be future proof in a way that I would prefer. Let's talk about ergonomics. Like let's start with Zig first. Do you have, when you develop Zig, do you have ideas of like, oh, this is how C did it, and I think we definitely should do it this other way? Do you have improvements over the C deficiencies?
I think if you watch my video, the Road to Zig 1.0, I think that's what it's titled. I sort of addressed this point in a way with some visuals that could be fun to look at.
Awesome.
But the way that I went about it was I said, look, C's mostly fine. Let's take it as sort of like clay and sort of like mold it into a better language, you know? So I think that's kind of in line with what you're saying.
That's excellent. I hope the moderators can link to that talk. I encourage people to listen to it. As for Odin, like I know I've seen the Odin website, and there's definitely a lot of like, oh, here's how C does it, and here's how we think would be nicer, that we've learned that this is a better way. Do you have examples of that?
Yeah, so pretty much everything you stated before, what you want in C, I added into Odin. Literally, like distinct types. You have break by default and case statements. In fact, each case statement just creates its own scope as well. You have default arguments for procedures, but not for structs, for good reasons. But yeah, it's all of this. But the thing is, I tried before programming and making Odin, for 6 months before, I tried making an augmented C, so literally a kind of a preprocessor to C to fix it. I tried adding new features to it, so I added try and do all that. I even added like the defer statement and stuff, which I absolutely love, which is scope exit if in like D language or whatever.
I miss defer too.
And Zig also has defer, yeah. There's so many of these different things, and I found after you cannot just augment C. C is actually fundamentally broken.
Oh my goodness.
Mm-hmm.
And the entire type system is very janky when you realize it. There's so many bugs that you don't even realize it when you go into other languages. It's just you cannot fix it like what C++ was doing. In fact, it's just broken. So I had to think, okay, what were the essence of C that I liked? And okay, take what I learned and the wisdom from it and do it from else there. Interestingly, the entire basis of like type system of Odin is Pascal based. It's ironic, but that's not technically ironic, but whatever. It's C based. It's not C based type system. It's Pascal. It's all very Pascal like, but with C syntax feel. It feels like you're programming in C when actually it's Pascal. But it is one of those things, and I wanted the essence that made C great, and I tried to get that as much as I could. So everything you were complaining about, I just added it in. It worked. For instance, string types, I added a decent string type to Odin. Array types, slices, I added them to Odin because they were stuff I needed, and these are the things I want to express.
Can I ask a quick question on the string stuff? Because there's one thing that I'm curious on how you solved there. How do you get the data, like the Unicode data? Do you just like update it with every release of the compiler?
Yes. It's the short answer is I've been doing it manually, but I'm going to actually have a generator, which I've been working on for the past couple of weeks. But the short answer is Unicode is Odin assumes that all file formats, all the files are in UTF-8, so all strings are assumed to be UTF-8 as well, which sounds like a weird idea, but it makes sense. If it's the worst, it's the least worst compromise, effectively. But for instance, in C. And actually, Zig doesn't do this. So Zig's strings are actually just byte arrays, correct?
Correct.
And you have different ways of expressing what type of array they are. Like, are they actually a pointer that's null terminated, or is this a slice that's null terminated, or whatever? You have all these different ways of expressing things. In Odin, I have an explicit string type and explicit C string type as well. Because for me, the semantics is a very difference between a string and a byte array.
Yeah. Well, I guess my question is like, let's say that the user does 2 upper.
Yes.
Where are you getting that data from of knowing how to do that?
So the final way at the moment it's in the library, and it's just Unicode tables pretty much, and you just look them up. And you need to make a whole full-on everything to do that, because I want a whole categorization of looking up stuff and doing 2 upper and 2 ling, and you do whatever, and it just does the entire Unicode. For instance, Odin has a built-in Unicode code point type, which is called a rune. Meets with Odin, it's a nice little name. And it's just a 32-bit signed integer internally, and it's signed for loads of actual technical reasons. But yeah, so instead of having char, which is in C, char is just a bite-sized thing. I have the concept of a code point instead, which is 32 bits. But C's is interesting, and this is such a again tangent. It's a very minor thing. C has 3 byte types, but one of them is specifically for strings, and because strings are even in C, they realized they was different than to a byte, like an array of bytes. There was something semantically different about them.
You're talking about char, unsigned char, and signed char, right?
Correct. Yes.
That's definitely tripped me up in the past. I'm not gonna lie.
Yeah. Oh no, it's tripped me up. But there's stuff like that, and you realize, oh, there's something there they found. Even if it's bizarre when you look at it, you're mixing integers with characters. They've got different semantics, but there's something there, and it's even those little things that we just forget about, and until you go, why? It's so fun. It's good finding stuff like this out.
Josh, do you find that there are ergonomic improvements that you would like to see in languages that are like C? So for example, I just mentioned a few, but I also think you might have some others, like in terms of like how structs default to certain values, or like I would love to see declaring variables that are immediately zeroed out, and then I choose to uninitialize them. In fact, I think I would almost never uninitialize them. I just feel that that's too dangerous. I can't trust myself. So that's one of the few. So that's one of the few things where I would want to be protected, right? Like the ability to not have garbage values and stuff like that. Do you agree with that, Josh?
Yes. Well, I mean, I have less ergonomic complaints.
Okay.
Of C and C++ than other people, I suppose. C++ and consequently C are relatively fine languages. The number of features you would have to implement starting from C or take away is quite small to make me very happy.
I guess your focus isn't so much as you need all these ergonomics, but like you have a small set of things. You already said that you are fine with like cramming everything into a single file, and like you're almost just focused on solving problems that are software problems more than language being in your way or a language not giving you something. Like sounds like you can just survive with whatever is given to you.
More or less. Okay. There are languages out there that weren't made as general purpose programming language that I would be perfectly happy programming in every day. For example, Fortran is a mathematics programming language for the most part, but it has extensions that make it usable as a general purpose programming language. And then on top of that, it has a number of features you wouldn't think you would really find in a procedural and functional language like it is, such as, in 2003, they added object-oriented programming, and they added some syntactic sugar in order to make that work so that you can feel good about it. But they also had type-bound procedures that let you overload multiple procedures into one name like you would with regular procedure overloading in C++, right?
Yeah.
So it's those types of things that make the language a lot more interesting and fun to use. And I don't think there's a huge disparity between Fortran 2003 and C for regards to what is missing in order to make C a more interesting and fun language.
That's a fascinating perspective. I think that this ties into what Ginger Bill was saying, which is you want to be the kind of person who can just jump in and out of languages all the time. And then you sort of like get the feeling of like, this is exactly what I need or exactly what I value. But if you don't have that desire to explore languages, then you almost come away feeling that the one language you are using is just the one way to do it. And then I almost feel like that's how some of the dogma comes in. It's like you just learn 1 or 2 languages, and that's fine. Like I only know 1 or 2 languages really, really well. But just like Ginger Bill was saying, if you learn 5 or 6 and just have fun with them, then it's a lot easier to not fall into like specific dogmas, which I was just saying earlier, like I have really specific tastes that maybe I could be more relaxed or actually find what's actually valuable if I explored a little more.
I think that's really good advice. Can I speak to something you mentioned earlier about leaving variables undefined?
Please do.
So I think that so you mentioned that you always want to zero initialize everything just to be safe. Yeah, like I like the better safe than sorry mindset. Yeah, I get that. I'm here to make an argument for why even in C you should leave variables undefined.
My heart. I'm kidding. Go on.
What?
I was like, my heart's aching. No, go on.
Oh, yeah. Now, to be clear, I think that if you can give a variable a meaningful value as soon as possible, you should do that. So you should minimize the amount of time before initializing a variable. However, I'm making an argument against initializing a variable with the wrong value, the wrong zero value before its time. So as an example, let's say that you're in C, okay? And you're gonna initialize, like, I don't know, maybe it's like a pointer to something, right?
Yeah.
And you're gonna do like an if statement, and in one branch you're gonna assign it to that thing, and in the else branch you're gonna assign it to the other thing, right? So no matter what, it's gonna get a non-zero value. Mm-hmm. But before the if statement, you're just like initializing it to null just in case. That's what I'm saying you shouldn't do. And there's a very specific reason why. Because you've done it, because you've initialized it to zero, you've semantically required that to be the meaning of the code. And if you, for example, forgot to initialize it in the else branch, the compiler would not be able to help you and tell you, hey, you forgot to assign the variable in this branch. It would be forced to think that you meant for it to be null. And it works, like, that's when the compiler can figure it out, which is great. But it even works at runtime too. So as another example, let's say it was more complicated, the compiler could not figure out that you forgot to do the right thing with the value. If you run it with a tool like valgrind can point out when you branch on an undefined value. And if you overwrite all your uninitialized variables with zeros, then valgrind thinks that they're supposed to be zero, and it can't tell you where you messed up. So the point that I'm trying to make is that you need to semantically communicate to your tools what the actual value is, and don't give it the wrong answer. If you can give it the correct answer, give it that one, but don't give it a wrong zero answer. You see what I'm saying?
Yes. So what would you recommend for, let's say I'm just writing some C code, and I have a pointer that is going to be assigned a little later, but do you maybe recommend declare the pointer, leave it uninitialized, maybe open a block inside the scope of that function, and do the computations required to assign the thing, and then you're good to go?
Yeah, try to give it the value as soon as possible, but don't give it a false zero value. You know what I mean?
All right, now that's fair. That's something I have to think about. It's a good advice.
In my view, though, I try and optimize for making the zero value useful by default.
I see.
So everything in Odin is zeroed already out. Everything is by default all initialized to zero. That's why there's no struct default struct values, because I want to kind of make the zero value useful. The reason as to why is because, well, let's just take a handle, for example, and you want to have a sentinel saying this is an invalid handle. Well, most of the time you could use 0, or you could do -1 or something like that. But the way I would do it is if your algorithm is dealing with it, your algorithm shouldn't matter. If it's 0, you put in 0 code, it will work. So you're still making it useful. Or make the default value, the default initial stuff, everything is Boolean, so it's false or something like that. And it's a different way of thinking about a problem in that regards. And it's not, I'm not saying the way Andrew prefers is bad or anything. In fact, I think it's a good way of doing stuff. It's just a different way of approaching a problem and thinking about, okay, what is the default value data? What is the default data, the zero data? Okay, how is the algorithms going to actually handle that?
So you're saying, let's say I'm using a library, and I'm going to call a function of that library that takes a struct as the argument with a bunch of values in it, and those are the arguments. They're inside a struct. And so if I if I clear the struct to 0 and I pass it into that function to do something, then all those 0 values, if the library writer is taking your philosophy into account, then whatever function call happened is going to be correct in some way, because those zeros have some default meaning assigned to it.
Yes.
Wait, so
Fascinating.
does that mean that all the pointers in Odin or the references can be null?
No. So no, this is where I'm going to disagree. I actually think I'm not even going to go there. I actually think null pointers are fine. I have no issues with null pointers. But I'm not going with references because actually references require specific semantics, so they're a bit more complicated. But anytime you've got a language with pointers,
Pointers.
you're screwed. But no, so pointers are slightly different. And I'll explain why I mean that. So a lot of the time when you're in C, you're passing a pointer to a procedure. It's either an in value or an in-out value or an out value usually, isn't it? That's what you're using a pointer for. And
Yep.
if it's an in value, you usually have to check, is it a valid pointer? Well, the only one you can really reasonably check is nil, a 0 pointer, or null, whatever you want to call it. There's more invalid pointers than that. But nil's the easiest one because it's the drunk man or a lamppost checking. Okay, that's the easy one to check, done.
Right.
And if you've got everything default to 0, it's easy to check as well. But a lot of the time is you've got the out parameters and you want to make sure they've been set parameters. Actually, no, you just want to return those values, which is where it goes back to the ABI question. How do you optimize for that? So really you want to just return multiple values. So Odin has multiple return values. I'm just saying,
So my
it's
question
depending
is,
on how
can
you...
it be null?
The answer is yeah, and I have no issue with that. If you want to use you want an optional pointer, you can do that as well. I actually find
Gotcha.
in practice, this is where I'll disagree. Null pointers are the least problematic pointers that are like an invalid pointer. They're really easy to find, really easy to check for. Even if when you're debugging, it'll hit straight away. The real dangerous ones, which are when you're doing any pointer arithmetic, it's those which are the dangerous ones,
Right.
which are very rarely 0. And you
Yeah, the
won't
use
catch
after
them.
free ones. Yeah.
Yeah, not use after free, and there's so many different problems that and it's again I say the analogy of the drunk man looking for his keys, and he's looking into the lamppost, and why is he looking at the lamppost? Because it's bright over there. But seriously, it's like there's a lot of harder problems, and for me, null pointers are not a biggest issue nowadays. 30 years ago, yeah, different. Nowadays, they're not. There's more complicated problems, and they're easy to deal with.
Yeah, so that's nice. So we've illustrated sort of two different perspectives on initializing things. And it's interesting how whether or not you have null pointers is related to whether or not you should leave your variables undefined.
Yeah.